Hello, hello all. Thank you all for coming back from the tea break. I guess it's really good from, coming back refreshed. Thank you, Tanya, for the amazing introduction. It's really warmed me up to be on the stage. Today, why am I here? I'm actually going to tell you a story about my dog. I suppose everyone here loves dogs, or maybe cats. The topic of my talk, topic of my talk is my dog ate the server. I will tell you why is that. Before that, I would actually like to thank Latency Committee for picking my topic because this is the perfect opportunity to make my dog famous. I don't need to create Instagram account for him anymore. Unfortunately, I can't bring my dog here, so I can only show you his picture, so you can tell I love my dog. For people who have dogs, you probably have the experience of you need to walk them a lot. My dog always gives me the face that he want to go for a walk 24/7. It's even worse when I'm working from home. It just always gives me the eye that I want to go out. So I'm trying to be good, so I walk him at least twice a day. So when it's coming to, walking in the park, he's really good, really friendly. So it sounds so good, he's well-behaved, but I've got a problem when he's running around in the park. So whenever he's in the park, he tends to forget who am I, just running nobody business, running away from anyone else. I try to get him back, shouting like a crazy woman in the park. So there was one day I was really mad when he was, running around, and I was running around like a crazy woman, people in the park looking at me like, what's wrong with you, and stuff like that. So I've decided that I want to do something about that. Started to think, can I put a GPS tracking device on my dog? So that I don't have to worry where he is. All I need to do is, take my phone and check where he's at, and then just grab him back. But when I look at the available GPS tracking device in the market, and I realize most of them are out of my budget, and most importantly, for the GPS tracking device on the market, I have very limited control over the data. So I started to be thinking that, can I build one myself? So make it a fun little project, make my dog a bit smarter, but not a robot. So before I start the project, I definitely face few challenges. I have very little knowledge on electronic device. So when I look at all the resources online, what need to be to get into to form a GPS tracking device, the more I look at it, the more confusing I feel. And also haven't get to the point where, because I want a device to be able to notify me the data, I haven't even think, how can I get it connected? Like either Wi-Fi, either through mobile plan, even better if I can get it to the cloud so that I can play around with the data. And at the point where you want to feel challenging, but not too challenging in a way that I actually don't know how to do it, and just want to give up. So I was thinking, is that a solution that is simple and easy to start? And of course, I actually got a solution. Otherwise, I wouldn't be standing here and sharing my experience with you. So this is the architecture diagram for my solution. I actually got the tracking device that is working by connecting to the server via the gateway. And the best part of this is the cloud server allowed me to integrate with the world of AWS. So how good is that? So I can now get the data to AWS and play around with all the services, get the data to the table, and I've got a React app that will grab the data via AppSync. So I did that on purpose. I walked through it really, really fast so that you don't remember, and you have to listen to me for the rest of 10 minutes what I'm going to do with that. So let's get started. So I said I've got a device, and this device basically solved the biggest hurdle that I have in the project. That device is good. It's pretty easy to start. It works by having a signal that allowed me to connect to the server via the gateway. So with all this spectrum, what is that? What device that I've got, and what is the server, and what is the gateway? I'm going to walk you through that. First, let's start out with the device. So the device that I have for my dog is a LoRaWAN device. So what is LoRaWAN? LoRaWAN is a wireless technology. It requires low power, and it offers wide range. So in another analogy, LoRaWAN is like your wireless technology at home. The difference for that is LoRaWAN offers longer range, and the device that connected to LoRaWAN requires way low power. So thinking of the benefit, it's perfect for my use case because it offers range from 5 to 10 kilometers. So I'm hoping my dog won't run out of the 10 kilometers, otherwise I won't know where he is, but that will be fine. And because it requires way lower power as well, so I don't have to worry that, I got a flat battery in the middle when he's walking, and you don't want to put your dog near to a power port all the time, right? So it's good. Now I've got a device. How can I get it connected to the cloud? So now I have to bring in the Thing network. So the Thing network, it's basically what I was talking about, the gateways and the server. It is a global community build project. I believe they have collaboration with 150 countries now. So in the picture there, that's basically telling you where are those gateways, and all of them are open source. You're basically free to use. Even in Perth itself, I believe they have more than 80 gateways up and running in the metro area. So when you want to start a LoRaWAN IoT project with the Thing network, all you need to do is just to check, are you in the range of the free gateway? If you're in, all you need to do is really simple, just register your device and you're pretty much ready, and that's all you need to do. You will be able to get the device connected to the cloud, and now you will be able to see the data in the Thing network console. So I was talking about all the gateway, the server, and the device, and how I actually get myself started. It's really straightforward. It's easier than I thought as well. First of all, you need to create an account with them. It's free. And once you've got the account, you need to register an app, of course. And then you need to register the device that you have within the app. The most important step here is you need to get the right unique ID from the device. So this is the ID that you're telling the Thing network that which device that you're going to do the registration for it. So that ID usually comes along with your device as well. So once you got that right, you got that configured, that's pretty much it. That's what you need to do. So once you've got that, they will locate the nearest gateway around you, and then once they're able to find the gateways, they'll automatically connect to the cloud because now you've got an account with them. I do have the link attached at the bottom. So for people who are interested to start, they have pretty good documentation about how you can get started and register your device. So if you have that done, you pretty much can see the overview in the console, in the Thing network console. You will be able to see all the configuration you have for the app and the device. So in the device overview, there is a status indicator, which I always use that to make sure that device is actually connected to the cloud. So by default, it's always had the status of never seen. That's because they're trying to locate the gateways, trying to locate the signals. If they manage to find, the status will change from red to green, and then they will tell you when was the last time the device actually connected to the cloud. So I also want to explain how the data actually gets sent to the Thing network cloud. So basically, LoRaWAN provides both uplink and downlink messages. So don't worry if you don't know what is that. When I first look at uplink and downlink, it doesn't make sense to me. It's just a type of message that's coming from the device. So uplink messages is a message coming from the device or the node to the network, whereas downlink messages is basically the message from the network to the device. In most LoRaWAN use case, you actually don't need downlink messages. And example, like what I use in my mini project, all I need is uplink messages because I only want the coordinates from the sensor, basically. I don't need to send anything back to the sensor. So for now, we can ignore downlink messages. All we care is uplink. And yeah, that's pretty much it for the registration process. And as I mentioned, it's the server, the Thing network cloud, offers an integration between AWS. I have that done via AWS IoT and Elastic Beanstalk. So the Thing network actually provides a cloud formation template for you. All you need to do is grab the link, go to AWS console, deploy the stack from the link. That's it. That's all you need to do. You probably need to do a bit of configuration based on the app ID and device ID that you have in the Thing network. So once that's done, the integration process are pretty much it. How can you actually verify it works? So imagine you have a device that registers in the Thing network. If you manage to get the stack working, you will be able to see your same device in Airbus IoT as well. That's when you know, okay, they are synced together. And so now, if the integration is working, you can manage your device either in Airbus IoT on the Thing network. It really depends on your preference, which one you prefer. So now I've got the integration working. I actually want the data to do something. I forgot to mention how the message gets sent from the Thing network to AWS. It basically works via MQTT messaging protocol. So what is MQTT messaging protocol? It is basically a message that will publish to a certain topic where the client can subscribe to the same topic to get the message back. So in the Thing network console, they will publish all sort of message type to its own topic. They have the format of the topic documented as well. So as I mentioned, all we need is uplink messages. So I went through the documentation and find the format of uplink messages. All I need is the app ID and the device ID for the topic. So now I know the topic, I know where the message is, and in Apps IoT, I actually need to set the rule to tell IoT where is that message coming from, and also I need to tell them what kind of data I want, because in the sensor, they're actually sending all sort of data that you don't need, and all I want is the coordinates. I don't care about all the other data stuff. So in the rule, I can actually specify the data that I want and also telling it where the message is coming from. Once I've got that configured, in the IoT action, you can kind of set the action where you either want it to store in a DynamoDB or you can use it to invoke a Lambda. I actually have it right into the table so that I can keep a records for it. So now we're talking about that one. And there's one day, I actually left my dog in a room with a server. I went for a work. When I came back, I realized my server is gone. So I suspect my dog ate the server. That's how I came up with the topic. So now my integration wouldn't work anymore because it was working with Elastic Beanstalk to IoT. I need to find another way to make it work. So when I looked through the Thing network integration method, I found another way which is even better, even easier to start, which is a HTTP integration. So, which is awesome because now I can go all the way serverless. It's easy to maintain. I don't have to worry about did I leave my instances up and running and then went for a holiday and came back, realized the expensive bill and stuff like that. So it's really simple as well. All you need to do is deploy a Lambda with an API gateway endpoint. The endpoint is the one that you're going to tell the Thing network for the HTTP integration. It's just you have to navigate to the Thing network console, go to the integration method page, telling them you're using HTTP integration. All you need is the endpoint of the API gateway, stick that in, and that's pretty much it. Your Lambda is pretty much ready to receive any message coming from the sensor. So this is really simple because I actually have that Lambda and API gateway as infrastructure as code. I have everything in pipeline, so I don't have to worry, account migration, or if I accidentally delete the resources, I have to do everything again. Also, it's pretty straightforward. As I mentioned, the previous method, it was coming from a template provided by the Thing network, so I wasn't actually fully understand what was the resources that are being deployed. It's basically just a stack that I deployed and it worked. It's just a black magic working under the hood, basically. So now I have everything working. That's the integration point where I change from Elastic Beanstalk and IoT to API Gateway and Lambda. So I've got the Lambda which will write the data to the table, which is this point. I've got the React app that is getting the data from the table via AppSync. So why do I actually choose AppSync and DynamoDB for my use case? It's basically a perfect architecture for serverless implementation. It's really easy to start. AppSync is a fully managed service from AWS for developers who want to start GraphQL API. It's connect to different data source. In my use case, my data source is DynamoDB. the best feature that I like the most is the subscription, which allowed me to get the real-time updates from the table. So how did I do that? It's via the schema. If you can see the picture on the right, it's basically how I define the type for my query, my mutation. Subscription is the one when I'm telling AppSync that I want to listen to this mutation, which is when the item get added to the table. So every time that something called the mutation, the component that listens to that subscription will pretty much get the latest data back from the table. So I don't have to worry about I have stale data in my table, in my app. I don't have to keep refreshing it and make sure that my dog is always on the right location. You don't want to get there and your dog is missing, it's not there. So this is the full architecture diagram flow. Now you can take your time to have a look. I have finished overall the flow of my solution. I've got the device. I actually got the device here with me today. That's more. It's pretty small. It will connect to the gateway, and the gateway will make the data go all the way to the server, integration with API gateway, and then all the way to Lambda. Lambda will write my data to the table, and then I've got the React app that will grab the data via AppSync. So I wanted to show you the app, like how it looks like. How can I know where my dog is? Just pretend you're very excited about it. This is my very simple app. It's basically just a Google map and a date picker, which I can query my data based on date. So if the date that I chose has certain data set, I will see all the black dots on the map, which basically is a coordinates that I get back from the sensor. Choosing different dates, if there's no data on the specific date, which means my dog is at home, or maybe he didn't bring the tracker out. So also the tracker, it's really small, which I really like it because my dog is really, really small. He's only like 3 kilos, so I think it will fit most of the pet in the world, or if you want to put it in your kid's bag, or I didn't suggest anything, but anyway, it's up to your imagination to, what you want to do with that. So I hope my talk will actually help to inspire you to start like an IoT project at home. It's actually easier than I thought to start. And I've got a full working solution that, I can pretty much drive my car and get my dog and solve my problem, saving my reputation from the neighborhood as well. Don't have to shop like a crazy woman in the park anymore. Thank you.